Imagine a country that literally started its space journey by carrying rocket parts on the back of bicycles and bullet carts. Fast forward to today, and that very same country is landing spacecraft near the moon's highly coveted South Pole, they're studying the sun, and they're actively preparing to send astronauts into deep space. Welcome to This Explainer. Today we're exploring the incredible rise of the Indian Space Research Organization, better known to the world as ISRO. This is not science fiction, guys. This is the true, incredible story of a nation that transformed from moving essential flight hardware on wooden carts to conducting world-class, groundbreaking science on the lunar surface. We're going to look at how ISRO went from being a resource-constrained underdog to one of the most respected space agencies on the planet. And more importantly, we'll see why experts believe India is gearing up to be a defining global space superpower of the 21st century. So let's get into it. Section 1. A Vision for Humankind. To really wrap our heads around how ISRO became this global heavyweight, we have to rewind to the 1960s. At the time, the global narrative around space was entirely dominated by the Cold War space race, a fierce battle for geopolitical prestige. But India chose a totally different, highly pragmatic path. In 1962, the Indian National Committee for Space Research was formed. By 1969, it evolved into ISRO, and in 1972, the Department of Space was created to oversee it all. From day one, their goal was incredibly grounded. ISRO's founding father, Dr. Vikram Sarabhai, laid down a really clear, bold mandate. He firmly believed that space technology shouldn't just exist for scientific prestige or to compete with wealthy nations. Instead, the goal was simple but ambitious. Use space tech to solve real-world problems. We're talking weather forecasting, communication, disaster management, agriculture, applying sophisticated tech to the actual everyday challenges faced by ordinary people. Former President of India and legendary scientist Dr. APJ Abdul Kalam perfectly reinforced this vision. As he put it, there was absolutely no ambiguity of purpose. India went to space not to flex its military muscle, and definitely not to show off to the world, but to lift up its people. This core philosophy of doing more with less while focusing strictly on societal impact literally became the DNA of ISRO. Section 2. Chandrayaan-3, the Lunar Leap. Fast forward to August 23, 2023, and this pragmatic underdog achieved something no other nation had ever done. India successfully landed the Chandrayaan-3 spacecraft near the moon's south polar region. And what really illustrates ISRO's modern genius is the hardware they used. Take the APXS, or Alpha Particle X-ray Spectrometer. This tiny sensor rode on the Pragyan rover, and the jaw-dropping part is that it weighs just 700 grams. That is roughly the weight of a loaf of bread. It perfectly encapsulates ISRO's talent for building incredibly efficient, low-mass, high-impact tech. Using this tiny sensor near the Shiv Shakti landing point, scientists successfully mapped the elemental composition of the lunar surface. Over a 103-meter drive, the rover took measurements and detected major components like silicon, aluminum, calcium, magnesium, and iron. They found the lunar soil there is remarkably uniform. Plus, scientists believe this polar region might contain water ice hidden inside permanently shadowed craters, which could be an absolute game-changer for producing drinking water, oxygen, and rocket fuel for future lunar bases. So, why do these soil measurements matter so much? Well, they provided direct, real-world evidence supporting the lunar magma ocean hypothesis. This is the theory that the moon's early crust formed when lighter minerals floated to the top of a giant, global ocean of molten magma. Interestingly, the sensor also detected heavier minerals, which suggests massive ancient asteroid impacts, literally excavated material from deep inside the moon. ISRO isn't just visiting the moon, they are conducting world-class science that is rewriting our understanding of its history. Section 3. Aditya L1, Touching the Sun. Right after conquering the rugged lunar surface, Israel immediately set its sights on our nearest star, the Sun. Now, obviously, you can't land a spacecraft on the Sun. So, for the Aditya L1 mission, the spacecraft traveled 1.5 million kilometers from Earth to a very specific, stable gravitational pocket known as a Lagrange point, specifically L1. Think of it like a cosmic parking spot where the gravitational pull of the Sun and the Earth perfectly balance out, which drastically reduces the fuel needed to stay in position. Stationed in this halo orbit around L1, the spacecraft gets something incredibly valuable, a continuous, completely uninterrupted view of the Sun. Because it sits outside of Earth's atmosphere and never has to deal with eclipses or planets getting in the way, Aditya L1 can constantly monitor solar flares, the Sun's corona, and powerful magnetic activity using its advanced payloads. The crucial question here is, Why study the sun from space in the first place? It is all about space weather. Powerful solar storms emit energetic particles that travel through space, and when they hit Earth, they can cause massive disruptions. We're talking about taking out satellite communications, GPS navigation, aviation systems, power grids, and the internet infrastructure that billions of us rely on daily. By decoding space weather, ISRO is helping protect modern technology all over the globe. Section 4. Space in Everyday Life and the Policy Shift. Predicting space weather brings us right back full circle to Dr. Sarabhai's original vision. Every single deep space discovery has to eventually benefit human life down here on the ground. Today, ISRO operates a massive satellite network that actively drives the nation's socioeconomic development. They're using satellite tech for telemedicine initiatives to connect rural patients with urban doctors, for forecasting natural disasters, monitoring crops, and guiding fisheries. Space is literally woven into the everyday fabric of the country. And this everyday infrastructure is driving a massive strategic shift right now. According to the groundbreaking 2023 Indian Space Policy, ISRO is completely changing how it operates. For decades, they had to handle all the routine manufacturing of rockets and satellites themselves. Now, they are officially transferring those mature systems over to private companies. This is brilliant because it frees ISRO up to focus purely on what they do best: cutting-edge research and deep space exploration. Section 5. The Next Big Leap. With the private sector stepping up to handle the logistics, ISRO is mapping out its boldest missions yet. The era of being the underdog is officially over. Take the upcoming Chandrayaan-4 mission. This isn't just about going back to take photos. It's a highly complex, multi-step operation designed to physically scoop up lunar samples and bring them all the way back to Earth. It requires a soft landing, robotic sample collection, launching back up from the moon's surface, docking in lunar orbit, and safely re-entering Earth's atmosphere. It's an intricate orbital ballet. And all of this sophisticated orbital maneuvering, advanced Earth observation, and new life support research, like the upcoming Gaganyaan human spaceflight program, is building toward one monumental goal. ISRO aims to put an Indian astronaut on the lunar surface by the year 2040. As we wrap up this explainer, I want to leave you with a thought to ponder. We have just watched a nation go from launching sounding rockets over small fishing villages to uncovering the ancient secrets of the moon's magma ocean. With ISRO now fully unleashed to focus on advanced deep space R&D and a hungry private sector taking over manufacturing, what is India's space ecosystem going to look like when that first astronaut steps onto the moon in 2040? Thanks for exploring this amazing journey with us.